Let's try to solve this 16th problem. So I'll find the largest value of xy subject to x square plus y square is equal to 2. So find the largest value of xy. So this is problem number 16 of probably part B. Subject to x square plus y square is equal to 2. Yes. Sorry. Okay, let's see how we'll solve this problem step by step. How to simplify it? That's the question. So we have to find largest value of xy, and x square plus y square is equal to 2. So the first question that should come to your mind is the following. The first question: how to make it simple? To make it simple, the problem will only be simple. Now, what are the two things that you can simplify? This one and this one. And what is the way to simplify? The way to simplify is to ask, when will two things become simplified? Sugar and water are two distinct objects. They will become simplified to a joules if they only dissolve each other, right? In other words, if there is any x and y, if they didn't dissolve, they will stay upon one another. They will be two distinct things only, like oil and water. So this thing will simplify. The volume of the complexity of this problem will reduce if xy and this equation have some relationship, right? That then the volume, the complexity of the problem will reduce, right? So the natural question is that, is there any relationship between any relationship of max of xy, you see the point, the largest value of xy with x square plus y square is equal to 2? That's a natural question from the curiosity that you can simplify the problem, right? That comes naturally. So therefore, what do you mean by max of xy? So first of all, x square plus y square 2 and xy, you see that there is some relationship like x plus y whole square is equal to x square plus y square plus 2x. Now you see the point that also you know a relationship probably that, so naturally this will tell you this. You may further ask the question, is in relationship with x square and y square and xy? Yes, there's a relationship that if x and y are positive, then this is greater than or equal to 2xy or non-negative. Why? Because this is equivalent to saying that x minus y whole square is greater than or equal to 0. It's equivalent to saying that. It's equivalent. So therefore, this tells you this, that so you replace xy is less than equal to something, that is max means xy is less than equal to that max, right? You can also rewrite like that. You see how the logical steps are. So once you ask this question, this naturally tells you that from this relationship, it probably you get the idea that x squared plus y squared is equal to 2, and 2 is greater than or equal to 2xy, and xy can take max values equal to 1. But x and y are not greater than or equal to 0 here. X and y can be anything, right? So the next natural again question is that if it will only simplify to this, it will only be simplified if somehow we can show that x and y has to be greater than or equal to 0, or if it's greater than or equal to 0, the problem remains same only. Okay, the largest value will also remain same. So let's do it. So this, see, every single time point I'm trying to simplify things and simplify things. So let's say x is less than 0 and y is, so 4 possibilities, right? Y is less than 0, x is less than 0, y is less than 0, x is greater than 0 or greater than equal to whatever. So in this case, x and y, if you multiply x and y, it turns out to be negative. So of course, in both these cases, it's not possible, because we know that xy is equal to x is equal to 1 and y is equal to 1 is a solution. So xy must be at least greater than equal to 1, right? So you know xy must be greater than equal to 1. You know that. The maximum value should be at least greater than equal to 1, right? Because you know x is equal to 1, y is equal to 1 is a solution. You can clearly see it right away. Or x is equal to 0, y equal to root 2. That means at least 0 is a solution. You know that. So therefore, the thing comes when x is less than 0, y is less than 0, x is greater than 0, and y is greater than 0. So now let's say that if x0 and y0 are both are less than 0, and xy is a solution, x0, y0 is the maximum value, right? Let's say this is a max value. You can say that I will take this minus xy and minus y0, which are both greater than 0. Still, this will be the same. So therefore, you can say for every negative x and y, there is a corresponding positive x and y, which gives the same x and y value. So hence, this set, the max of this set, is equal to the max of this set. And x and y are both greater than 0. So the why we did, so if I suddenly wrote this equation right in the beginning, you would have no clue where did this come from. The clue came from the very fact you want to simplify the problem to this case. That means this tells you that, okay, I can now just focus on x and y. Like, what if x and y are greater than or equal to 0? Whatever the maximum is in that case, that will be the ideal solution. Because the negatives don't matter. All of you understood, and this is a problem. This is the reason problem is given, okay? Otherwise, if it was already given x and y greater than or equal to 0, so this is the most important point. If it was already written x and y greater than or equal to 0, it wouldn't have been a problem at all because of this relationship. It's an AMGM inequality, it's called. So all of you understood this idea, that why did we want to do this? We want to show that the negatives really don't matter. We can leave them aside because the same max value we will be getting in the positive domain, non-negative domain. So, and in non-negative domain, it's easier to work because of this relationship. Now, initially, if you started to think, oh, I cannot apply AMGM here because this x and y are not negative, not positive. How can I apply AMGM? And then you would have moved in a different direction altogether. Just because you assume that the problem is hard, you cannot simplify it, and then you went out to a different direction. Rather, the other way is the best way to solve any problem is simplify the problem and see where you're getting stuck, and see if you can remove that stopper. Is any way, mathematical way. Can any result that can, or can you engineer any idea that can remove the stopper? That's all the way. That's how every problem is solved in the universe. Solve an easier version, see what's blocking it. That's how new theorems are coming up, new ideas are coming up. I can do this, I cannot go to this step. What can I do to go to that step? And then that new thing is done. And it goes on iteratively. We have reduced the problem down to the single positive domain. So now we can see that x and y greater than or equal to 0. We have x squared plus y squared is equal to 2. And we have this equation that if this is true, right, x is minus greater than or equal to 2xy. So we get xy is less than or equal to x squared plus y squared by 2. And we see this is a maximum value, and we know x squared plus y squared is equal to 2. So this maximum value is 1. We already know that x is equal to 1 and y is equal to 1 is a solution, right? Because this gives x squared is equal to, so is a solution. So you know that we know xy is equal to 1 in this case. That means the maximum value of xy should be greater than or equal to 1 from here. Either this is the maximum or there is something more than this. If something is less than this, that is then 1 is the maximum. If something is better than this, then xy is that value will be the maximum. So xy is always greater than equal to 1. And from this we get xi is less than equal to 1. So the maximum is xi is equal to 1, where x is equal to 1 and y is equal to 1.